Hi everyone, thanks for coming. So my name is Ben Kappa. I'm a software engineer at Red Hat and I'm based in Waterford, Ireland. So today I'm just going to talk to you about the smart farm and optimization use case in the Green.Da.AI EU Horizon research project. So just a bit of a disclaimer before I start. I don't actually take any credit for the work that's completed in this use case. I'm just kind of providing the dissemination aspect for the use case at this conference. So the work was led by ITC, a company from Slovenia, and all credit goes to them and the partners that are developing the services that are used by the use case. So just run through what I'll be discussing today. I'll give a general overview of the project, just as context for the use case. Then I'll give an overview of the use case itself, including the goals, KPIs, and objectives. Then I'm going to talk about the 3 use case scenarios, which everything is centered around. Then I'll talk about how the use case leverages and integrates the applications that are used by the farmers. And then finally, I'll discuss the AI services which are used in the project before touching on the potential future innovations. So onto the overview. So what is a Horizon EU research project? Basically, these projects drive innovation in Europe. They attract research and innovation investment. They enhance collaboration between the public and private sectors to overcome major challenges that the EU faces. So these projects tend to have over 15 partners. And these can range from like massive tech companies to smaller specialized companies, research facilities, and universities. And these projects really strengthen the EU's position as a world leader in science and technology. So Green.Da.AI, what actually is it? The project really does kind of what it says on the tin. It's all about green energy, data, and AI. So it's the goal is really to establish a data space and also creating sustainable AI services that are leveraged across the 6 use cases in the project. And these use cases span across different industry domains like agriculture, transport, EV charging, and banking. So first of all, let's define what a data space actually is. So you can kind of think of it as like a platform that lets its participants, usually big organizations, to both freely share their data or monetize it while maintaining full control over who can actually use and access it. And also the project is after developing over 20 AI services which are used by the 6 use cases. Now, that started off as 9 in the project proposal, and over time it's ballooned out to over 20. So the what and the how of the project then. So basically we want to harness the transformative potential of AI combined with data spaces, and this is going to help contribute to the green transition that's laid out in the European Green New Deal. So how are we going to do this? So the aim is to develop energy efficient and large-scale analytics services that are ready to use in industrial AI-based systems while reducing the actual environmental impact of these data management processes. So there's 5 main objectives. The first one obviously is to define the architecture. So we need to create the data management framework and obviously the reference architecture for the system. Then we need to develop the energy efficient data analytics services. And then we move on to making sure that we balance the energy efficiency with the performance of the system. Because obviously if you lean too hard into energy efficiency and you sacrifice too much performance, then the system isn't going to be adopted. So if you're going to balance energy efficiency with performance, obviously you need to be able to actually measure the energy efficiency of the AI services. And finally, we need to operate the 6 use cases across various kind of industry domains, like I said, transport, agriculture, banking. And these really show the viability of the system in a real life setting. So then just a quick overview of the actual use case itself. So obviously to keep European agriculture efficient, competitive, we have to be able to adopt new technologies. So obviously 2 big ones are AI and 5G. And these can work towards providing valuable insights about crops, pests, ideal harvest times, that sort of thing. So that's what this use case is all about, and we'll get into the different services and models which made that possible later. So these are the 3 use case scenarios which basically the whole use case is centered around. First of all, we want to be able to optimize the fertilization of farmers' fields. So we need to be able to inform farmers of the optimal fertilizer usage. And this is not just uniform across a whole field. We'll be able to tell the farmer how much fertilizer to use in specific zones in the field. Then we move on to harvest and optimization. So this is all about predicting the crop development for maximum yields, and also providing the farmer with like the optimal sequence and route to actually harvest their crops to make sure that they're using as little fuel and resources as possible. And then finally, anomaly detection. So this is providing the farmer with an early warning sign of imminent outbreaks or other anomalies. So this can be like human intervention, can be weather, pests, diseases. So to support this, we have 3 objectives. The first is to integrate all the data sources that are coming in. So we have a lot of different data sources like external weather systems, IoT devices that are actually in the fields, satellite imagery, lab samples. And all this data is going to feed into being able to generate the maps. So we use a platform called the Gemma Fusion Suite, which is leveraging the AI services to create maps, and they're fed into the application that the farmer is going to use. So that application that the farmer is going to use is MyFarm, and this is basically an application that was developed by ITC over the last few years in collaboration with farmers advisors, the Slovenian government, really to try and digitize farming in Slovenia. So then we have the use case KPIs. So really, this is all about reducing the actual time it takes to carry out these processes. Obviously, we also want to reduce the amount of resources that the farmers have to use. Reducing the amount of resources reduces the costs and usually improves production. So then a bit more information about the 3 different scenarios. So the first one is optimization of fertilization. So we want to be able to create, predict how much fertilizer needs to be used in specific zones in the field. And to know how much is actually needed, we have to understand like the vegetation health in the field and across different areas in that field. And to do this, we use IoT sensors combined with a metric called NDVI, which stands for Normalized Difference Vegetation Index. And put simply, that just means how much green, healthy vegetation is actually present in a particular zone in the field. So with all of this data collected, the farmers can use the MyFarm application to just go on, generate a report that provides the maps, which are going to be overlaid onto basically a Google Maps type kind of application, and basically show the farmers exactly where the different zones are in the field. And it's going to generate a file called a shape file, which can then be imported into the farmer's onboard computer in his tractor, and he can hover over things to see exactly how much fertilizer is needed, the type of fertilizer that's needed, and when to do it. So then the second scenario is the optimization of harvesting time. So this is all about finding the perfect window to actually harvest your crops. So you can see in these 4 images, the first one up at the top was in July 11th, the bottom one is in July 16th. So this is the progression of the crops over about a week. Now, you can see in the legend, it starts with green and at the bottom and goes up to red. So green means that basically the crops are young, they're still growing, they're quite dense. And red means that the crops are starting to lose their chlorophyll. That's a natural process. It means that they're drying out and becoming ready for harvest. So using this information, we can basically predict exactly when the farmer needs to harvest these crops. So yeah, basically you can see the progression. So the farmer can obviously then go back into MyFarm again, select all of the fields that have this particular type of crop in them, generate a report, and then the report will basically tell him the optimal route for harvesting each of these fields, the optimal window for each field, and yeah, obviously that is going to reduce the amount of time, the amount of planning that's required for the farmer, and obviously reduces waste. So then the third scenario is detecting anomalies in a field. So again, we have 4 images which are kind of showing the progression. So up at the top left, we have, this is a near-infrared satellite image, and you can see of a 7-hectare barley field. So we can see up at the top left that it's a very homogeneous pink color running through the whole field, and that's what you want to see, really. It means that it's grown in a uniform way and that there's no real issues detected. Now, in the bottom one here, you can see that these lines have started to appear. This was taken about a week later from the same type of satellite. And basically, this means that the crops are not grown in a uniform manner anymore. There's something happening which is causing an anomaly. So at this point, the farmer can see something is happening with his crops. He needs to go and basically inspect it. First of all, he can use satellite images. I can't use that. Up at the top right, that's a high-resolution satellite image. It just basically gives them a bit more insight into kind of how the crops look in a real-life kind of scenario. And you can see that these lines are there, and there's obviously something wrong with how these crops are grown. So at that point, he can either go out and visit the field himself, or he can use a multispectral drone to go and get an aerial kind of view of the field to see if he can identify what is actually wrong. So at the moment, we can't actually tell him what the anomaly is. It could be pests, diseases, weather, human intervention. But obviously, with more data points, this is a prediction that we could start making given more time. So then the application integration. This is really centered around MyFarm. So this is kind of the top view of the MyFarm application when he logs in. So you can see, it's not shown, you can see all of the different fields that he has on his farm. And if you hover over any of the fields, it'll give you just basic information about it. But then you can see the 3 buttons above the map: harvest optimization, pest detection, and targeted fertilization. So these are a button for each scenario. And when he clicks these buttons, in the back end, the predictions are going to happen, the maps will be generated, and they'll be populated onto this map. So these are quite old images. It's been updated since then, but it just gives a good idea of what's happening. So here you can see the different colors representing how ready, I suppose, the harvest is. So the farmer will know which fields are ready for harvest, which are not. Then pest detection, again, you can see the different color fields. So red obviously means there's something going on in that field, and he can go in and take a closer look. And then targeted fertilization. These are the types of, this is a very early version of the shapefile that would be generated. Now on the next slide, it's a much more kind of up-to-date image. So this is the fertilization report. So here are the list of fields that he has of a certain crop. So if he expands one of these, you can see the particular zones in that field. And if you click the button over at the far right, one of these, then that will actually populate this shapefile onto the map. And these can be exported and then imported into the onboard onboard computer in the tractor, and basically guides the farmer to be able to optimize their fertilization and put exactly how much fertilizer needs to be on that particular zone in the field without using too much or too little. So then the AI services. So the first of all is the data foundation. So this is where we make sure that we have the right data in the right format. And the orchestration framework is basically gathering, cleaning, and combining information about the farm. So it handles data fusion and satellite image pre-processing. Then we have the data ingestion service, which is pulling in external data like weather forecasts, other IoT sensors. And then onto predictive intelligence. So we have the behavior modeling pipeline, and that's needed to create digital twins of the fields. That helps predict crop development, and even uses advanced techniques like cloud removal. So it cleans up the satellite images for a cleaner map of the fields, basically. Then onto the explainable feature learning. So this improves the accuracy of the crop growth predictions, improves the accuracy of spotting pests or other anomalies, and also allows us to actually helps create the farm maps. So then the event detection service is providing information like crop health maps. It guides harvest optimization, and it also helps generate the fertilization maps. Then finally, the weighted federated learning is basically using the AI model. And it focuses on fertilizer estimation, and it also provides privacy preservation, meaning that any data that is kind of produced from the farm actually stays on the farm. It's not shared with anyone. So this is the workflow. Basically, we start here with the raw data. That data is passed into the Gemma Fusion suite, which I'll show you in a second. This platform basically manages and stores the data, and it's pulling in external data from the data ingestion service. Then that data is used in the next three boxes here to predict and create the maps. So we're creating the harvesting, pest and disease and other anomalies, and the generation of fertilization maps. And obviously all of the services above are the ones that I just mentioned, and they're all feeding in and helping create the maps in the Gemma Fusion suite. So finally, all these maps are fed into the MyFarm application, and the system is constantly being monitored, and the farmer can provide performance or any feedback that he has. So this is the Gemma Fusion platform. So I'm not going to talk in too much detail about this. Basically, I just want to show the different maps being created and laid on top of each other, which can then be fed into MyFarm. And once they're in MyFarm, the farmer can choose the specific map that he wants. They won't be laid on top of each other anymore, and they'll be fed into the reports that he generates. So you can see this is the weather, etc., and then it overlays it onto the specific fields that he has. And this is the final result that gets fed into the MyFarm application. So what has been the impact of the kind of AI services on efficiency? So we have quite a significant reduction in energy usage. So the feature learning is a 94% reduction. The optimized models, so AI, has provided a 50% reduction in energy usage, and for inference, Onyx has produced a 42% reduction in energy. So then that obviously helps us with accurate predictions, optimized resource usage, improves the yield of the crops, and it allows for proactive management based on data-driven decisions. So the future innovation then is really it's all about continuing and refining the models to be able to give the farmer more information. So it focused mainly on providing deeper data insights, or even gathering kind of more diverse data points to uncover more connections. So this is how we might be able to tell the farmer exactly what anomalies are actually occurring. Like, is it pests, diseases, weather, humans? So we need to look at factors like soil structure, the amount of rain that's actually coming down on the fields, the amount of sun that's coming down, and all of this leads to better predictions and improved, that's going to lead to improved decisions and impact. So it can also reduce false alarms. So yeah, that's it. If you have any questions, I'll try and answer them, but remember, I'm not the technical lead on this or anything, so if you have some very technical questions, you can always email me and I'll come back to you with some answers. So yeah, if you have any questions, please go ahead. Yeah.
You talked about energy reductions.
Yeah.
Energy reductions of what?
Yeah, so I actually have some notes here. So, oh, sorry. Energy reductions of what and who. Yeah, okay. So the explainable feature learning, that was a 94% reduction, and it was measured during the automatic discovery of representations from input features. So there was 2 experimental configurations that were tested, one with a maximum of 10 output features with 10 generations, and another with a maximum of 16 features within 20 generations. And the energy consumption of these 2 configurations were compared. So the tests were conducted on a system that's basically running the energy efficiency benchmarking tool that was developed in the project. And yeah, it resulted in a 94% reduction. So that's all the information they gave me for this project. But if you want to give me your email address at the end, I can come back to you with a proper answer. So for the TER-AI model, that was measured, basically the total energy consumption of the TER-AI approach was measured across 3 configurations, so small, baseline, and large. So the difference between these configurations was the number of channels within the hidden downsampling layers. So 4, 8, 16 for small, 24, 36, and 48 for baseline. Yeah, yeah, exactly. The models that are actually. Yeah, exactly. Yeah. Sorry, I haven't done any technical work on this. I'm just kind of providing the dissemination for the use case. So is there any other questions?
Has anybody put this into production?
Yeah, so this is actually being used by farmers in Slovenia at the moment. It's being tested because the MyFarm application was already an existing application that's being widely used in Slovenia by farmers. So it's been pretty much rolled out across farming in Slovenia, and it is, well, we haven't actually tested the KPIs yet. That's starting, the testing and validation is starting in the next couple of weeks. But the kind of feedback that they're getting from farmers is that it's very helpful. It is reducing the amount of time that goes into planning. It's reducing the amount of resources that they're using, and they're noticing excellent production results. Any other questions? Oh, sorry.
What is your opinion on if this is also applicable to like deforestation or plantation, not only farming?
No, it should be applicable. Oh, sorry. Could this be applicable to other areas like deforestation or just yeah, any other kind of area? So it could be. Obviously, you'd have to make some adaptations to the predictions, the maps, but like you could, a lot of these AI services are being used across multiple different industries. So we have electric vehicle charging, we have banking, so fraud detection and banking. So yeah, these AI models can actually work across multiple areas, and you could definitely use it to produce maps for deforestation or anything else really.
I also heard about some techniques and how you can plant with like drones and stuff, because you showed us that there are like the anomaly detection, or where are areas you need more fertilizer. Then how can you do this with the normal tractors you have, or do you need to change also the equipment you have?
So the question is, how can we do we need any kind of adjustments to the equipment in the tractors, or can this just be kind of done in any tractor? Basically is the question. So at the moment, they're working with farmers that have already been kind of integrated with the MyFarm application. So all of these tractors have onboard computers that can have the shape files that are produced by the reports imported into the onboard computer, and these do work with the actual computers that guide the farmer up and down the field, etc. So it depends on the tractor and the computer that's actually in the tractor, but they should be pretty much compatible with the majority of farming equipment, because they're all pretty much set up to do similar or the same things. So yeah. Any other questions?